All right, so this is, I'm not going to tell you what the function is. We're just going to focus on how to write the limits. Because the function, whatever the hell it is, I'm just going to throw it in the middle. It's going to tell me maybe which way to do it first, dx dy or dy dx. But it's not really going to affect how to set up my limits in those two cases. It's independent of the true surface itself. So here they're sort of saying, well, what are they kind of implying here? If I wanted to integrate across this region from a surface.
From 2x squared to 1 plus x squared?
Yeah, what's x doing? X is going from
Negative 1 to 1.
negative 1 to 1. Well, that's one way to look at it. As x goes from negative 1 to 1, what does y do?
Going from 2x squared to 1 plus x squared.
Okay, let's set that up. So based on what I just said, what do you think is going to be the interior, what's going to be the exterior? That's a weird question to ask right now. Let me see if you guys can figure it out.
Interior is going to be the y and the exterior.
Because what's this line represent related to what I showed you earlier with I was moving them back and forth, and we're talking about the green area and collecting all that green area. This is the green area. The above it, let's pretend like the surface is up here. I don't know what the function is, but can we all just be cool? Let's pretend the surface is right here. Above this line to the surface, that's going to be that green area. So the inside has to be d what in that case? Yeah, I want to move along this, and if I want to move along this, obviously I'm letting y change. So for a specific x value, y goes from this to that. So the interior is going to be dy, exterior is going to be dx. Another way to tell, would you want to do this, well, let's set this up. Dx is easy. What's it doing?
Negative 1 to 1.
Negative 1 to 1. What's dy doing?
2x squared, 1 plus x squared.
Yeah, 2x squared up to
1 plus x
1 plus x squared. Cool. And then the function could be anything. Now, some of you guys like shortcuts, and I love it. The problem is we don't know when we're not allowed to use them sometimes, and we use them, overuse them. So one shortcut that's really nice in Calc 1 and Calc 2 is to realize when your region, your area you're doing is symmetric. So you just cut it in half and then double it. What's wrong? I'm just going to tell you right now that's wrong here. What's wrong with doing that here? Because is that symmetric?
Yeah.
You don't know if the surface above it is.
Beautiful. It's all about what the hell the surface is doing. I mean, if the surface is symmetric, then you could do that. But it could be doing, it's not. It doesn't have to be symmetric across that. Again, you can put in your own whatever sound effects you like.
Do we not know that though, because we're only doing these certain given points?
Right now, I haven't told you what f of xy is. You have no idea what that is. And actually, for what we've done, it doesn't matter. The only thing it could change is I might want to change my order of integration. Now, can somebody help me? Why would I probably not want to do that here? Why am I hoping to God they gave me a function that works the way I've got it set up?
Because then you would have this weird thing with your limits. You'd have to somehow...
Oh, it would so suck, even worse than you realize. If I let y go from 0 to 2, is that cool? You guys see that? Mm-hmm. X would go from what to what? Well, you'd have to figure out, solve this for x. It would go from the negative rad to the positive rad. And then what happens here? What happens after you pass this point? Now it goes from that to that, and then from that to that. Oh my God. So not only will the function's ability to be integrated help you figure out what order to do this in, but also the ability to write the limits without having to have multiple integrals. But you do the same thing you did in Math 180. You would split up the integral from here to here, and then from here to there. And that would be just gross.
What the x values?
You'd have differences between functions. I don't want to think about it. All right. But if I said, let's say that this function is, what you got, Jeff? I don't know, Jeff. What if it was, just make something up? That's going to be gross. Oh yeah, I'll just make it x. Sure.
Plus what?
Yeah,
No,
it won't be too bad. Thinking like x times y. Sure.
Because that's just
Thinking
gonna
that's
make it
fine.
0.
All right, now. So here's this skill in its own right, is to really make yourself realize what's a constant and what isn't. And again, like I said, if I wanted to, what would I be allowed to pull out of here? Now, if it was x plus y, hopefully you understand you couldn't pull it out of there. It's not multiplication, so, right? But here, if you wanted, you could pull x out. But hopefully, after we've done all that partial differentiation, you're able to attack these things more directly. Now I'm integrating, though. Well, let's just integrate this thing. How do you integrate y dy?
1/2 y squared.
Yeah, so it'll be x, y squared over 2, from
2 to,
2x squared to 1 plus x squared.
and you just plug an x in, right?
So another thing I want you to realize is, can the outer limits, good show, can the outer limits ever be functions themselves? Yeah, but normally no. You want to end up with an actual answer. You want to end up with an actual number. So the inside is where the functions exist. That tells me the walls that I'm going between. The outside has to be numerical, so I end up with a number at the end.
Can you not compute those limits yet? You know what I'm saying?
You could, because I'm just going to get, well, here you couldn't, because I need the full function of x before I integrate.
Right.
If they were just numerical, of course I could wait. Yeah.
So how you attack the integral really depends on what functions you have in the scenario, right? Because otherwise you can run into this crazy.
Yes. You have a lot of sometimes competing things telling you what to do. If I gave us a function that I could not integrate dy first, I would be forced to turn it around, because even though it's gross, I could still deal with the multiple integrals. It's possible to do. So it's a question of, is it a different way? Okay, I could do it that way. Or is it possible to do it and impossible another way? Well, guess what? No choice then, right? Yes?
So the reason you integrated with respect to y first was because it was easier?
That's what we're trying to make it easier.
Okay.
Yeah, and
So
this one
it is choice.
Yeah, there is some choice involved, and this one was sort of obvious because of the fact that if I wanted to integrate with respect to x first and y second, I'd have to know what x was doing, and that would involve negative and positive radicals, and then a switch here, because here it's still going from that wall to that wall, but the minute I'm past this point, now it's going from there to there, and from there to there.
Okay.
Okay, so
Gross. Truly gross. You guys remember doing this? You guys remember having to figure out which way you wanted to do things based on, did you have to write it some weird way? Was the integral possible to do? Same considerations. Just one extra little layer on top. So normally this is going to be where any function limits are. And this is normally going to be numerical, so that at the end we end up, if this was non-numerical, then I would be plugging in functional values. I wouldn't end up with a number. Does that make sense by itself? I'm not saying it's impossible to have these, as it isn't, but normally this is going to be numbers. So what do we get in the inside here?
you actually just
So now you're plugging in that entire function, right? And then you plug that in.
negative 3x to 4 plus 2x squared plus 1 over 2.
So you get x, this will be x to the fourth, plus 2x squared, so it'll be negative 3x to the fourth.
That's 2x squared
Plus 2x squared
plus
plus 1 all over 2. And then you bring the x in. I like it. Do you see how if you're, what's up?
I get 0.
It's possible. I just made that function up, you never know. Let me think about it. Yeah, because here the x values are positive, and here the x values are equally negative. Right? So x, y, that function is going to be up here and down there symmetrically. So it sort of makes sense that I end up with volumes that are canceling each other out. Who cares if you get 0 though? It's fantastic. What's wrong with that? I don't know if it feels like you've done all the work for nothing, but I'm like, that's awesome. I took all that weird shit and made 0 out of it. It's awesome. All right, but somebody asked the question earlier about do you have to plug these in? Obviously you do if they're functional limits, because I don't know what the inner function is until I've done that. And it's exactly like plugging numbers in. You just plug that in, get a function, simplify it, bring the x in, polynomial, easy to integrate. You do get 0, kind of makes sense looking at the symmetry of the problem.
Yeah, because then it's all odd.
Yeah, it becomes all odd. So when you integrate across from negative a to a of an odd function,
It becomes all even.
I like it. All right, how do you guys feel? So I'm trying to show you, it's really weird trying to figure out the order to throw things at you, because I know there's specific skills you have to be able to apply in order to do a complete problem. So one skill is just writing the limits themselves. Then the skill is going to be, what if that comes out to you, it's impossible to do? How do you switch the limits then? And that involves, of course, rewriting these in terms of the other variable. Yes?
Couldn't you just do the integral from -1 to 1 x y dx, and then the other integral from 2x squared to 1 plus x squared around that?
No. Do you mean just turn these around?
Yeah.
No, because then I won't end up with a number at the end.
Why not?
Because you're going to plug, if you did this, are you saying just to do this here?
Yeah.
That? So obviously when you integrate your last, when you do the inside and you get whatever the hell it is,
Yeah.
then you're going to integrate one more time, and it's going to be, well, that would be dy. Then these values have to go in.
Okay.
Okay. Do you see what I mean? So whatever this is, whatever this function is, well, it could be x or y. When you integrate it, you're going to have to plug these values in. And so you're not going to end up with a number. You're going to end up with some expression. Doesn't make sense. Yes?
So that way you're starting with, like just a line, or a horizontal line from -1 to 1, and that's not quite
Exactly. So it's,
so down there.
the interior integral is controlling these, is being controlled by these walls, and the exterior integral is really not. So if you did -1 to 1 inside, then like you're saying, I'm going to have these lines drawn, and that's not what I'm trying to integrate over. I'm just trying to integrate over this piece. So I have to have that restrictive part on the inside. Between what walls am I integrating? Yes.
So back to that case, you said it has no meaning. Does it have no meaning in this context, or does it have a meaning and that might be an expression that represents all points that are...
Good. Depending on, for this problem, this wouldn't make any sense, but there are situations where you can have this to be functional, and that would be, then it would be a volume function. Right, so I could do from 0 to x dt here, and then it would be the volume function. Same way you got an indefinite integral, right? So you can have indefinite multiple integration, but you could do it in a prescribed way where it goes between these two different walls. So there are situations where you want to do that. We're nowhere near those situations here, though. I want to make that clear. Yeah.
So the y equals x squared is the bottom. That's the bottom of the y. That's kind of like the.
Yeah, this is the parabola. Yeah, 2x squared. And this is the bottom parabola, goes through 0. This is the top parabola. So that's why I said, we said that y went from 2x squared to 1 plus x squared. I like it. So you do, let me give you these, let me try to work on this.
What's the arrow again? The arrow going, the blue arrow.
So this kind of thing, you should have done something like this when you were talking about switching limits of integration before. Depending on if you want to do the x or the y axis. Or even when you're doing washers and discs, you know, talking about the radii and stuff like that. I want you to realize this is not washers and discs, but part of this feels that way. Finding the drawing these lines in should feel that way. So this is kind of like the inner radius or something, right? And that's not really, but it's the same kind of feel to it. Let's do this. The less colorful side for right now. Well, you know, dessert there. Whatever gets you through.
The gray side.
The colorful side stretches. No. The one that's mostly gray. So here I haven't given you a function. I've just given you a region over which I want to integrate some function. Oh, scheisse. I love knowing how to say shit in several languages. All right. So what I'm asking you to do here is, can you write the integration in the correct order to make at least the limits easy to deal with? Yes?
Does this first one go to like 3 or just 2?
Yeah, there should be a hard line there, but it didn't want to. Good question. It stops at 3 on the x-axis. I like it.
So we're just making the limits of integration.
Exactly. So you're going to put like an f of xy inside, because we don't know what that is. You guys are doing that side. You want to this side first. The less colorful side. That one's at the next level. I like it though. You guys are attacking. Trying to forget that means you didn't listen to what I said. That's all right. Now, real quick, before you guys leave this first problem too far behind. So this is what I mean. I just want some function in there, right? So what order? This is pretty obvious, hopefully. What's going to be the interior? What's going to be the exterior? What's going to be first here? dy. Why?
Because
Not just because I gave it to you. Look at me giving d. Get out of it. Not just because I gave it to you in terms of x, right? But what's the real reason that I wouldn't want to do it the other way?
You have to find the
Here,
x.
you have functions because of...
Because if I try to do, so right now you're saying do it this way, where I draw the lines like this, and I agree with you completely. Because if I wanted to try to do it the other way,
there's some values where it doesn't.
Then you have.
You'd have to find that.
all right. Yeah, this would so suck, because right here it go from 0 to this, right? You have to solve for x, y over 2, and then here it would go from this wall to that wall, and then here it would go from this wall to 3. So you'd have 3 double integrals to set up. Do you guys see the consideration? That's what I'm trying to point out to you is you'd hope to God the function is differentiable dy, so you don't have to turn that around. That would so suck. What goes here on the inside? I like it. And then on the outside? Yes. And then x goes from 0 to 3. So just always do this for yourself and make sure it makes sense. This is what y is doing. This is what x is doing. Right. I know this is trying to be an x. Now real quick, I want to do one more step of this. If I let the function be 1, if I put a 1 in there, like this, So now I'm going to tell you f of xy equals 1. So what kind of surface would that be? If I tell you f of xy equals 1. And what is f of xy really?
Oh, Z.
Z is 1, so it would just be,
Plane.
this is a nice normal roof, right? Oh, thankfully, right? This is your flat roof. I like it. And, here it's fine because we don't get snow. We don't need this kind of thing. Now, but I really go one more step. Integrate the inside. What do you get when you integrate? What's the interval of 1 dy?
Y.
That's crazy. It's y. Let me see what it is. Y. And it's going from 2x to x plus 4. And of course, when you plug those in, you'll get 0 to 3, you'll get x plus 4 minus 2x. Now, I know you could all finish that out, but what does that really represent then?
Area between the two curves.
Yes, isn't that the area between those two curves? If I let the function be 1, I'm basically back in Math 180, because now I'm saying there is no real volume. I'm just picking up the area itself. You guys follow? I'm letting the thickness be 1, so it's really just going to be something that represents the area itself, which is Math 180. That's why this agrees with the way that we do integral areas between two curves. You just take the difference between the curves. It's amazing. Just to show you that it's consistent with what we've done before. You're like, well, okay, that's nice, Jeff. All right, so how about this guy? So if I draw a line like this, is this the way I want to do it? Like that. Do I want to do it this way?
No,
Why not?
it's no good.
What is it? What is that? He says it's no good? It's no good, man. Just don't do it that way. Why do I not want to do it that way? Because I'd have to set up how many integrals? I'd have to set up more than one, which is bad, right? Because right here, things would change. I want to go, and also, solving this would involve a negative radical and a positive radical. You guys come with me? And I probably don't want to have limits inside that have radicals, because the integral might be difficult to do, possibly. Yes?
I was pointing, I'm sorry.
Oh, sorry. You're showing me. Hey, it's up there, Jeff. Oh, thanks. So this, I don't want to do this, and this would be letting what change? What am I following here? As x, well, I just gave it away. So this would be as x goes from there to there. So I don't want my interior to be dx then, do I? I don't want that. I want this. I want to let my y go from something to something, because then it's consistent all the way through. That's what drawing that line helps you do. So what this means is, I want to let the interior one be dy. And so what am I going to put? Here's my f of xy. What's the limit's going to be?
2x squared.
Yeah, from 2x squared to 2x plus 24. And then the outer one will be dx.
Negative 3 to 4.
Yeah, exactly. Negative 3 to 4. And again, I then will tell you what the function is, and you can maybe see, do I have to switch my limits around? But what we've just done is independent of what that function is. It all depends on what makes sense with the input point. Okay? Now, if I knew what the function was, and this was impossible to do, then I'd have to switch things around. Oh, shit. What about the one that has color here? This one's neat.
Y squared minus 3 times.
Now, really. So this will involve you drawing rough sketches for yourself in the XY plane.
Do you have any dx, dy?
Yeah. Or what do you definitely not want to do first? I don't want to do this kind of thing, because what would that entail? Oh crap. and the changes, oh shit, I don't want to do that on the inside. So what do I want to do on the inside? The other way, Jeff. Oh. So I want to do this. This makes it nice. So that's my inside then. So I want integral what on the inside?
Y minus.
Integral
y
d
minus
x. Just put an F there. As x goes from what to what?
Y squared minus 3.
Yeah, y squared minus 3 e to the y. And that is another clue, the fact that both of those, well, where am I at? E to the y is not that bad to turn around, but the y squared minus 3 would involve a negative and a positive, right? So it kind of tells me how I want to set this up. And then the outer one is going to be integral from dy from what to what?
Negative 1 to 1.
Yeah, it's like staring in the face. From negative 1 to 1. So as my x goes from that wall to that wall, I'm going to scan and pick up all those areas as y goes from negative 1 to 1. Does that make sense how to say that? So I can find all the areas, and then I want to go from negative 1 to 1 and add them all up. I like it, I like it. And of course this dude. So now watch. If you do this, can you do it with one integral?
Yeah.
No,
What happens right here?
it's not continuous, is it?
Changes. So here the top wall is 2x. Here the top wall is 12 minus 2x. Now I'm not saying that it would be impossible to do it that way. I'm saying that if I can, I'm going to do it the other way. I don't want a couple of double integrals. Right? I'd rather have just one double integral. So I already doubled the work from before. So more than likely, I want to go this way, because then I can go from that wall to that wall, that wall to that wall. But this will be, the interior will be integral d what then?
Then it would be dx.
Yeah, dx. As x goes, so then I need to go from, as x goes from what to what, right? So I really want to, so when we did this, we wanted this, and this is what y is doing. Y is changing, and that's why the inner one was y. Do you guys see what I'm saying? So if I want to draw this, I can eliminate the stupid way to do it, or the way that I hope I don't have to do it, and I can go here. But when I draw these lines, it's telling me what the interval is going to be. I want to let y go from this to this. I'm drawing a vertical line that's parallel to the y-axis. It's got to be what y is doing. So here I'm drawing parallel to the x, is what x is doing. So I can't use this. I need to know what x is doing.
Right.
So I just have to solve those for x. I think I overheard somebody say that, which kicks ass. So x equals
6 minus
sure
y over 2.
6 minus y over 2. I like it. And here x equals
Y over 2.
y over 2 is great. So it'll be the integral as x goes from
6 minus.
careful. Starts here and goes there, right?
Yeah. Y over 2.
X goes from y over 2
To 6 minus y over 2.
y over 2 to 6 minus y over 2. Let me stop there for a second. You guys see that? That's why drawing that line, a rough sketch of your input region, and then drawing the line will help you set up your double integral. And then, this is f inside. dy integral, what's y doing? 0 to 6. So for any value of y that I want, whatever this value is, it's between 0 and 6. The x's are going to go from this wall to that wall. That's related to the question I had earlier about why you can't have the outer limits having the x's in them or something like that, because I want the interior one to be the restrictive one. Maybe. Okay, and then the rest of this, if I told you what the function was, the rest of this would just be applying integration. So if you have any trouble with integration, you're going to want to go back over that.
I'm just trying to remember what you said. You said we couldn't use for the inner dy because
Well, all right, let's do it.
the point it changes. You said something like that.
Poor Jesse. People gonna. But let's try it. If I wanted to do it this way, what would that first, the integral up to here, what would it look like? If I do it this way, what's the inner interval going to be? dy, because I'm going in the y direction.
Right.
So the interval is going to be dy. What's the limit's going to be?
0 to 2x.
Yeah, so y is going from 0 to 2x. I love it. So from here to here, it's going from 0 to 2x. 0 to 2x. Is that, you guys see that?
Okay.
So 0 to 2x. And what's x doing? 0 to 3. I love it. So then I just add, of course, because I only did half of this thing. And again, you can't just double that because I don't know what the function's doing. Integral. The inner integral again is dy, but now it's going from 0 to
12 minus 2.
0 to 12 minus 2x. I love it. And x is going from 3 to 6. So as x goes from 3 to 6, the y values go from this wall to that wall. So I could do 2 double integrals, because right in the middle, my walls change. If I had to, if that function I couldn't do, if I couldn't do it the way we had written first, if it was impossible to integrate, then I would do this first.
Okay, so it
And I would hope that once I do this first integration, it would end up with a function that the other one could tackle. And that happens very often. Once you do the first integration, the function becomes something that the other one can handle. But the way you wrote it first, maybe it's impossible to do it by hand. All right. All right. Most of you guys are still awake. So this we'll do next time, I think. This is like a complete